Welcome to Multiple Choice Question 17 of the 2009 Mathematical Methods Exam 2. In this video, we will be looking at the solution for this question. A reminder that this video is in no way endorsed by VCAA. And now before we move on, I'd just like to point out that the use of a CAS calculator is not appropriate for answering this question. For question 17, we have the sample space when a fair 12-sided die is rolled is given by the integers 1 to 12. And we're told that each outcome is equally likely. The question goes on to ask for which one of the following pairs of events are the events independent. So this is where you might like to refer to your notes to remember that independent events are ones where the probability of A intersecting B is equal to the probability of A times the probability of B. So there's a bit of a process involved in answering questions like this, and I'll take you through it for each of these options now. So if we look at option A, I'm just going to set this question up as follows. I'm going to let event A be the first event that's listed. So that is the set of 1, 3, 5, 7, 9, and 11. Event B, I'm going to set up to be the second list that's given. So that is the list of 1, 4, 7, 10. And then I'm also going to calculate the event that is A intersecting B, which is going to be the set of outcomes that are common to both. So if I just get a highlighter out, we can see that 1 is in both of them, 7 is in both of them, and 4 and 10 don't appear in list A, so they're the only two events that are common to both. So A intersecting B will just be 1, 7. The next thing that I'm going to calculate is the probability of each of these. So the probability of A is going to equal 6 events, all being equally likely, so it's just 6 out of 12, which is equal to 1/2. For event B, so the probability of event B is going to equal 4 events out of 12, and 4 out of 12 can simplify to 1 on 3. And the probability of A intersecting B is going to be 2 events out of 12, which equals 1 on 6 when simplified. So the next thing I'm going to do is test for independence, which is essentially just testing if this equation holds true. So therefore I'm going to calculate the probability of A intersecting B using that formula. So we're going to want that to equal the probability of A, which is 1/2. So we're going to have 1/2 multiplied by the probability of event B, which is 1/3. And multiplying those two things together, we have 1/2 times 1/3, which will give 1 on 6. And then we need to check if that's equal to the actual probability of A intersecting B, which is 1/6. So because that is true, we can conclude that those two sets are independent. So that means that option A is the correct answer for question 17. Now, I'll just go through the tests for the other 4 options so you can see how you'd approach those. But obviously, now that we've found that A is correct, you could just move on in an exam. But if we have a look at option B, we're going to set up the same test. So I'm going to let A be the first list that's listed, and B is going to be the second list that's given in option B. And we can check that the intersection of those two lists has no elements in it, so it's the null set, which is what that little symbol down here means. And then the probability, if we've got 6 outcomes in A, is 6 out of 12, which is 1/2. B has 6 outcomes, so it's 6 out of 12, which simplifies to 1/2. And the null set, A intersecting B having no elements in it, means the probability of A intersecting B is 0. And from there, we test for independence. So we multiply 1/2 times 1/2, which equals 1/4. And we can see that that doesn't equal 0, which is the actual probability of A intersecting B. So we conclude that those two events are not independent. And the interesting thing for option B is that because we have A intersecting B being the null set, it actually means that A and B are mutually exclusive events, which tricks a lot of students in these sorts of exams. For C, if we do exactly the same thing, we're going to let event A be 4, 8, 12. Event B is just going to be 6, 12, and the intersection of those two things, so the things that they both have in common, is just the object 12. So the probability of A is 3 out of 12, which is 1/4. The probability of B is 2 out of 12, which is 1/6. And the probability of A intersecting B is 1 outcome out of 12. and then we do our test for independence, and we go a quarter times 1 on 6 equals 1 on 24, which does not equal 1 on 12. So these two events are not independent. And now if we look at option D, we're going to let A be 6, 12, and B is 1, 12. So the intersection between them is just the object 12. The probability of A is 2 out of 12, which is a sixth. The probability of B for this is going to be 2 over 12, which is also a sixth. And the probability of A intersecting B is 1 outcome out of 12, which is 1/12. Testing for independence, 1 on 6 times 1 on 6 is 1 on 36. That does not equal 1 on 12, so these two events are not independent. And then if we quickly do E, we're going to have the event A is 2, 4, 6, 8, 10, 12. Event B is 1, 2, 3. The common elements to both are just the outcome 2. So the probability of A is 6 on 12, which is a half, and the probability of B is 3 outcomes out of 12, which is a quarter when simplified, and A intersecting B's probability is 1 on 12, and then we test for independence and check if 1/2 times a quarter equals 1/12, and it doesn't, because a half times a quarter is 1 on 8, so because that doesn't equal the actual probability of A intersecting B, we conclude that those two events are also not independent. So again, we found at the very start that option A was the correct set of events that represented independent events for this sample space. From the examiner's report, we can see that 31% of students got that question correct, and there was a very large amount of students that got B for that question. So more people selected the wrong answer B than the correct answer of A, and that's because they confused independent events with mutually exclusive events, which keeps being a common mistake on these sorts of exams. So just make sure you do know the difference between independent events and mutually exclusive events when you do questions like this.